Action.
Hi, I'm Dora, and today I'm going to be going over a Let's Practice question from Topic 14, Video E, Stoichiometry Problems. Consider the reaction of butane, C4H10, with oxygen to produce carbon monoxide and water. If I want to produce 140 grams of carbon monoxide and the reaction runs to 75% yield, how many grams of butane and oxygen do I need to start with? By reading this problem, we can tell that it's actually a backwards stoichiometry problem. And by reading this problem, we can also tell that butane reacts with oxygen to make carbon monoxide, which is CO, and water, which is H2O. In order to start solving the equation, first we need to balance the chemical equation. As given in the question, butane, C4H10, reacted with oxygen. As we have learned, oxygen is a diatomic molecule, so on its own, it would be O2, not just O. The products, carbon monoxide and H2O. To start balancing, we want a balanced number of coefficients on each side. Putting a 2 in front of butane would give 20 hydrogens and 8 carbons. In order to have the same amount of hydrogens and carbons on the opposite side, you would put 8 in front of the carbon monoxide and 10 in front of the H2O. Therefore, you have 18 oxygens. In order to have 18 oxygens on the reactant side, you put a 9 in front of the diatomic oxygen. To start solving the problem, first we have to find a theoretical yield. As given in the question, we found that we have 140 grams of carbon monoxide left over in the reaction. With the 75% yield, we want to find out the amount lost in the reaction. So you would do 100 over 75. Normally we would do 75 over 100 because we would be looking for the amount lost, but this time we want to find out the amount started off with in the product, in the reaction side. So you do 140 times 100 over 75, which gives you 186.7 grams of carbon monoxide. That's the theoretical yield. Now, with the amount of 186.7 grams of carbon monoxide, you want to convert it to moles. So then you can use the ratio to find out the amount of butane and oxygen you started with. So 187 grams of carbon monoxide times 1 mole over 28.01 grams per mole. The 28.01 is the molecular weight of carbon monoxide found in the periodic table. With that, you then cross out the grams, which gives you 6.68 moles of carbon monoxide. To then find out for butane, you reduce the 6.68 moles of carbon monoxide times the ratio of butane to carbon monoxide, which is 2 to 8 in the balanced reaction. So therefore you would do 2 over 8, which gives you 1.67 moles of butane. To find out the grams of butane, you then convert the moles of butane to grams of butane. So you would do 1.67 moles of butane times its molecular weight in the periodic table, which is 58.12 grams per mole, over 1 mole. And then you would cancel out the moles, and you would get 97 grams of butane in the original reactant of the reaction. Then to find out oxygen, you do 6.68 moles of carbon monoxide, the same that we used in the butane, times the ratio of oxygen to carbon monoxide, which is 9 to 8. So 9 over 8 equals 7.52 moles of diatomic oxygen. Then you convert the moles of diatomic oxygen to find out the grams of oxygen. So 7.52 moles times the molecular weight of oxygen. Since we're using diatomic oxygen here, you want to take the molecular weight of oxygen and multiply by 2. So therefore you get 32 grams per mole over 1 mole. And then you cancel out the moles, and you get 240 grams of diatomic oxygen. So this tells us that in the reactant of the chemical reaction, we had to start off with 240 grams of diatomic oxygen and 97 grams of butane in order to get 140 grams of
Carbon monoxide
with a 75% yield. And that's how you solve the let's practice question of the backwards stoichiometry problem. Bye.